Hello everyone, my name is Luke Hanks and this is my Lab 2 video for Physics 2211. So the purpose of this lab is just to investigate the properties of objects that fall from rest, including the forces that act upon those objects. And the way we're going to do that is by performing an experiment and analyzing the motion through tracker and then making two models in glow script, one with the gravity only and one with the gravity and drag force. So the principles involved here include Newton's second law and the gravitational and drag forces, the equations for which are shown on the screen. And as you'll see, the results are going to show that including drag makes the model much more accurate at approximating the experiment. So here's my experiment. I dropped a paper ball. It's pretty simple. Alright, here's my first model, gravity only. And I won't play the whole video because it's like 20 seconds long. Alright, I'm sure you get the gist of what this looks like. Here's my second model with gravity and drag. And again, I won't play the whole video, but take note of the force vectors you'll see. And if this model were to run long enough, eventually the force vectors for gravity and drag would be become equivalent, and that's what we have as terminal velocity. Alright, let's move on here. Here's my coding. Oh, not yet. This is just my data, my first graph, and my only graph actually. So the blue line is the experiment position, and as you can see, if we have just gravity, it's fairly inaccurate, but if we have drag as well, it's almost a perfect model, but it's not perfect because there's always sources of error, and I attributed the error to be video distortion. I also didn't know the exact mass of my paper ball, and there could have been a change of airflow in the room that made the net force on the ball something different than what I anticipated. Alright, now here's my coding. So here's my gravity and drag model. So what I had to do was change the time to be less than 0.766 seconds, because that's how long my video was. And so for the net force, I just changed the net force to be the weight plus the drag force. So the weight, as you can see, just the ball's mass times g times j hat, and then for the drag force is just b times the magnitude of the ball's velocity squared times j hat, and b is just a proportionality constant for the drag force. And so the net force is going to become weight plus the drag force, right? And then the object's velocity and position I just changed to be the velocity update and position update formulas respectively. And finally, you can see at the bottom, I just had to add those lines of code just to make the force vectors appear on the models. And then I had to change the mass of my ball to be 0.0045 kilograms and the proportionality constant to be 0.0030, which was obtained by guess and check just to make sure the final position of the model and the experiment to be equal. And so for the for the gravity only model, it's just the same thing. You just take out the drag force. Alright, so what does it mean? Examine the velocity versus time predicted by your model with and without drag. Which models, if any, predicted terminal velocity? Discuss briefly. Alright, so here we can see the graphs. The left one is with gravity only, the right one is with drag force. And as you can see, only the drag force produces a terminal velocity because terminal velocity is when the gravity force and the drag force are equivalent. When they're equivalent, the net force is 0 and the object has a constant velocity that we call terminal velocity. If there is no drag force, you will have no terminal velocity because the ball will just accelerate infinitely. Alright, the what if. Imagine that the object was initially thrown downward. What would the terminal velocity in this case be? Would the terminal velocity in this case be the same or different from the case where the same object was initially dropped from rest? Basically what that means is, will the terminal velocity be different if you have an initial velocity input? And so as you can see, you cannot tell the difference between my two graphs. One of them has an initial velocity input and one of them has no initial velocity, and as you can see, they both eventually reach the same constant terminal velocity, which shows that an initial velocity does not have an effect on the terminal velocity. Alright, that is my Lab 2 video for Physics 2211. Thank you for listening.